we finally got to the last step of the challenge, which happens to be my favorite one. And in this step, we're going to generate CloudFormation templates dynamically using Stacker blueprints. Now, Stacker has this feature, which is called blueprints. You can even click on this link here, and it's going to take you to their website. But blueprints are basically Python classes that dynamically generates CloudFormation templates for you. And it's actually built using Troposphere, which is a Python library used for that. And you might think, okay, so why do I need to generate my own CloudFormation template? Why can't I just, why do I need to generate dynamically? Why can't I just not write it myself? And I'm going to give you an example. Imagine you're in a follow situation. So you have a pipeline, and you want your pipeline to be able to deploy a VPC with a certain number of subnets. Now, you do not want to calculate the subnet addresses yourself. You want the pipeline to be able to do that. But you only know two things. You only know the VPC address, and you only know the maximum number of hosts per subnet that you want. But you don't know the addresses. So you want your pipeline to dynamically figure that out. How many subnets are going to be needed, and also the address of each one of the subnets. To give an example here, if you have a VPC address of 10.0.0.0/16, and the maximum number of hosts per subnet, it's going to be 8,190 or 8,192, your pipeline should be able to figure out that you're going to need 8 subnets, and these are going to be the addresses of the subnets. And also here you can notice that the subnet mask is going to be /19. So before we code anything, we first need to understand how can we get to /19 and to all of these addresses given the VPC address and also the maximum number of hosts per subnet. So I'm just going to go here on the whiteboard and we're going to figure this out together.
In order for us to calculate the subnet addresses, we need to find out the subnet mask. If the VPC has a net mask of, let's say, /16, and we want to split that /16 into a number of subnets, and each one of the subnets is going to have up to 8,192 IP addresses, then what's going to be our subnet mask? So that's what we need to find out. I'm going to start by defining a variable here. And this B is going to be the max number of hosts per subnet. And this is something that we're going to get because we're going to get the network address and the number of hosts per subnet. And let's say that I have an IP address that ends in /32. This is an IP address that ends in /32. And we know that this is a single IP address. Yeah. So this translates to a single IP address. If I have /31, that's going to translate into 2 IP addresses. If I have /30, that's going to be 4 IP addresses. If I have /29, that's going to be 8, and so on. And what we're looking for is the subnet mask. On the right-hand side, we know that that's B. Yeah, so that's the number of hosts per subnet. I'm not going to use B here. I'm going to use an actual number, so the calculation is going to be a little bit easier. So I'm going to use 8,192. Now, if you take a look at this, you have 1, 2, 4, 8, 16, 32, 64, 128, etc. So we know that this is an exponentiation. Yeah, this is really 2 to the power of 0. This is 2 to the power of 1. This is 2 to the power of 2, 2 to the power of 3. And now what this is 2 to the power of something. I still don't know. Let's call it x. And what we need to do here is to try to find x. To find x, we need to isolate x. And this is an exponentiation. If you want to isolate the x in this case, we need to use something which I'm sure you've heard about, which is called logarithm. And logarithm is basically the inverse function of exponentiation. So if we want to write this in log notation, it's going to be log of what? Of this 8,192. What's the base of the log? Base 2. And that's going to give us x. Once we know x, it's actually very easy to find out the subnet mask, because look at this. So you have 32 minus 0, that's 32. 32 minus 1, 31. 32 minus 2, 30. 32 minus 3, 29. So you just have to calculate x and do 32 minus x. That's gonna give you the subnet mask. In this case here, x is 13, so 32 minus 13, that's gonna be 19. So our subnet mask in CIDR notation is /19. So that's what we're looking for. Now there's one thing here that we need to be careful with, is 8,192, that's 2 to the power of 13. But we know that we're not gonna get this number of IP addresses in our subnet, because the first one and the last one, they're not given to you, because that's the network address or the subnet address and the broadcast address. And so we would end up with 8,190. And on AWS, it's actually worse because they take 3 more. Yeah. So you would end up with the number minus 5 instead of minus 2. And if you provide your Python script this number instead of this, you're gonna get a little bit of a different result. So instead of 13, you're really gonna get, if you put 8,190 here, you're really gonna get 12.9999, etc. And if you take 32 minus that, that's gonna give you 19.000 whatever. And that means you're gonna have a float as a subnet mask. And we don't want that. We need an integer. We need this to be 19. And what we're gonna be doing is, let's first write the formula. So the formula is gonna be 32 minus log base 2 of what? Of b. That's the number of hosts. Okay. And like I said, if you end up passing a number which is a little bit less than the actual number of IP address, that's gonna give you the subnet mask, but in a float, as a float. Yeah, and we don't want that. So what we're gonna do is take the floor of this. So if this is gonna give you 19.000, when you get the floor, that's gonna be 19. And to do this in Python is very simple. If you use the math library, there's a function called floor. So you just put that into that function, and that's gonna give you an integer. So this is really the formula that we're looking to implement in our Python script, which is a pretty simple formula. No big deal. And so yeah, so let's go back to the challenge and try to implement this.